Assalamualaikum warahmatullahi wabarakatuh to Dr. Jeffrey. My name is Farhad bin Hashim and we would like to explain the assignment of stainless steel mechanical properties and its structure that was given a few weeks ago. Okay, first and foremost, I would like to explain the introduction of our assignment. The Petronas Twin Towers is the tallest twin skyscraper in the world. One of the reasons that make this skyscraper is a miracle is depend on the materials. We were given choices to the material to use in this project. So we select the 316L stainless steel because it made the criteria needed for this project. Okay, next, the problem statement is which 316L stainless steel is the suitable for skyscraper like the Petronas Twin Towers? There are two conditions of the 316L stainless steel that can be used in this project, which are normal 316L stainless steel and cold roll 316L stainless steel.
Assalamualaikum warahmatullahi wabarakatuh. My name is Faris Hafiz bin Hairul Nizam. Today I will continue our presentation and I will talk about the technical finding. The austenite phase in austenitic stainless steel is not a stable phase and will transform into strain-induced martensite during the plastic deformation process. Martensite phase generally exhibit a higher strength and lower plasticity. The strength of two-phase materials are determined by the volume fractions and the corresponding strength of the two-phase. Austenite phase will turn into martensite phase and the strength of the cold rolled austenitic stainless steel will improve. The standard used for the tensile test is the ASTM-E8 method, which covers the tension testing of metallic materials in any form at room temperature specifically. In the method of determination of yield strength, yield point, tensile strength, elongation, and reduction of area, the strength of and ductility is determined by the tension test of material under unaxial tensile stress. This is the machine. Grip and face selection is in the STM-E8 are important to obtain accurate result. Specimen alignment is key to avoid any cause of bending moment and side loading of the 316L SS. The room temperature shall be 10 to 38 degrees Celsius unless otherwise specified. The values stated in SI unit are to be regarded as separate from each per pound units. The values stated in each system are not exact equivalent, therefore each system must be used independently of the other. The purpose of the tensile testing is to see the relationship between the stress and strain relationship for the material. The kind of deformation of the specimen 316 LSS, either plastic or and elastic deformation, can be seen in this experiment. Graph 1 and graph 2 is stress strain curve of 316 LSS specimen and cold 316 LSS specimen. This is the graph 1 and this is the graph 2. For the original 316 LSS specimen, the maximum applied load is 10.38 kN, while cold 316 LSS specimen is 8.02 kN until both specimens are fractured. The elastic deformation is the linear between the extension and the applied load. Engineering stress is the ratio of load applied to the original cross-sectional area, while engineering strain is the difference of length or elongation during the load placed over original length, delta L over L naught. So that's all from me. Thank you.
Assalamualaikum. My name is Fahmi Azlan Fauzi, student for 1 EKG section 2. For the technical finding, we can compare the true strain and stress curve for both the same specimen, one for the normal one and one after the process of control. So we can see the difference between the curve as to see the effect of changes in microstructural for material, which can increase the extent of centerline segregation, and it also decrease the grain size and more distribution of crystallite. So if you can see the difference between the two curves is the scroll curve is um, more strength than the normal one. So we can conclude that the core roll will affect the uh, performance and also the mechanical properties of the steel because it can elongated the grain also with the steel itself, which make the steel increase in term of strength and hardness. Next, we can see that the difference between the curve is the coral curve has a better modulus Young and a longer deformation between plastic and elastic uh, deformation. So we can conclude that the mechanical properties are affected by the changes in microstructural for each material.
Assalamualaikum, my name is Muhammad Fisari Benisa. Relationship between microstructure and mechanical performance. We can see from the graph 1 and 2, the yield strength of the cold rolled stainless steel is higher than the original sample. By the calculation, the cold rolled stainless steel yield strength get 95 megapascal and for the original sample get 45 megapascal. By cold rolling the stainless steel, the strain induced was formed during this process and it could improve the strength effectively. Because of the high density of the grain boundary, which can hinder the movement of dislocation, can reduce the stress concentration and improve the strength of the sample. For the tensile strength, the original sample of the stainless steel is higher than the cold rolled stainless steel, which by calculation, the original sample get 114.75 megapascal and for cold rolled stainless steel get 99.74 megapascal. The deformation of the microstructure is formed during the plastic deformation, but it is depends on the deformation mechanism. By cold rolling the stainless steel, the dislocation boundary was formed. It happens because of the shear band comprise the slip band of the stainless steel. The dislocation boundary of the stainless steel cause the different slip system. With the high density of dislocation grain boundary that caused by cold rolling, it is difficult to slight contribute to its poor plasticity. So by this relationship, we can conclude that by cold rolling stainless steel, the elongated grain are produced, the smoother finish, and it also increase the strength up to 20%. Metal hardness also increase, reduce grain size of the metal, and higher quality finish. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nubari bin Muhammad Fazani and I'm from 1BEKG S2. For my part, we explain about the conclusions. For the first point is 316L stainless steel famous for its outstanding corrosion resistance. It has been used for traditional routes such as forging, extrusion or casting. However, the traditional routes are not suitable for make a complex part by use this material. It is time consuming and costly since it is using machine. If we use welding method, the corrosion of the 316L stainless steel will be affected. For the second point is there are two innovative ways, which are laser engineered net shaping or LENS and selective laser melting or SLM. SLM is one of the innovative approaches of the laser additive techniques for the manufacture of near net shaped parts. Through this technique, the near net shaped part can be produced in one single step that cut down time and cost. The SLM part increase both yield and ultimate tensile strength of the 316L stainless steel as compared to the traditional process.